The classification of a compressible flow takes place on the basis of Mach number, which is defined as a ratio of a local speed divided by the local speed of a sound. This Mach number can be greater than 1, can be less than 1, or can be equal to 1. According to that, the flow will be classified as sonic, subsonic and supersonic. Alternately, the Mach number is given by inertia force divided by elastic force, and you have to take the square root of this term. So based on the Mach number, if we have a Mach number is less than 1, it is called as subsonic compressible flow. If we have Mach number equal to 1, it will be called as sonic. In the case of sonic, the velocity of sound is same as the velocity of fluid. Here V represents the velocity of fluid. And if we have Mach number is greater than 1, it is called as supersonic. So we normally classify into three categories. One is sonic, subsonic and supersonic. In the case of supersonic, the velocity of sound will be less than the velocity of the fluid. And in the case of subsonic, the velocity of sound will be greater than the velocity of fluid. So Mach number becomes a paramount importance in a high speed flow where density becomes significant. Consider here a sea level. We'll just check here the concept of Mach number. At sea level, we have temperature of air is 300 Kelvin. And let we have the aeroplane is flying at the sea level with a speed equal to 600 km per hour. So this time we can calculate the Mach number at the sea level. So for this purpose, we have to calculate the velocity of sound, which can be done by using the gamma into R into T. Gamma for air we can take as 1.4, gas constant we can take as 287, temperature we can take equal to 300 Kelvin, that is T0 value. So this temperature is same as T0. So we have velocity of sound is 347.2 meter per second. And right now we have velocity of fighter plane is 600 km per hour is 600 divided by 3.6 is 166.67 meter per second. So we can very well calculate the Mach number at sea level, which is V by C is 166.67 divided by 347.2, that equal to 0.48. So this right now a Mach number is 0.48, which is subsonic, is less than 1. Now let us assume here we have a altitude equal to Z equal to 8 km and we have a standard temperature lapse rate equal to 6.5 Kelvin per kilometer. And now the same fighter plane is traveling at a same speed equal to 600 km per hour, which is same as 166.67. So at this temperature here will be equal to T0 minus lambda times Z. So we have T0 is equal to 300 minus lambda is 6.5 and Z equal to 8. So temperature at the altitude of 8 km we can calculate. Since it is under the stratosphere, we have taken a standard temperature lapse rate of 6.5 Kelvin per kilometer is 248 Kelvin. So you have to calculate here the velocity of the sound at Z equal to 8 km, which is equal to under root of gamma RT. Gamma is 1.4, R is equal to 287, and this time we have to take the temperature at 8 km, which is 248. So this time we have velocity of sound at 8 km altitude will be 315.66 meter per second. And correspondingly we have Mach number at Z equal to 8 km will be V by C. So the speed is remains same, that is same as equal to 166.67, and this time we have velocity of sound is 315.6. So Mach number is different for the same plane having a same speed of 600 km per hour is 0.527. I will make it 0.53. So this time we have Mach number is 0.53. So remember here Mach number does not give you any idea about the speed. Here the speed of both jet is remain same, but since it is lying at since this is flying at low altitude, its Mach number is 0.48. For the same jet, if it fly at altitude of 8 km, its Mach number become 0.53. So this one is a little idea about the Mach number. Using the Mach number, we'll define here Mach cone, the zone of silence, the zone of action. That is, we are going to discuss here the propagation of sound wave for different Mach number. To define the Mach cone, let's consider here the idea about the pressure field due to a source. First consider we have a stationary sound source. So this one is stationary sound source and it is developing the sound in all directions with a velocity equal to c. So in the time it will cover a distance equal to c multiplied by t, and we have a sphere here. So anyone inside here we can hear the sound with a radius equal to c multiplied by t. During the 2t time we get a sphere here, and our radius will be equal to 2 times of c multiplied by t, and continuously we will get a wave propagation here, that is called as the pressure field due to a source. In this fashion the sound wave will propagate in all direction, that is a spherical. And when the sound source itself is moving with a velocity equal to v, we will consider three cases. The first case is velocity of the source is less than the velocity of sound. Second case we have the velocity of the source will be equal to the velocity of sound. And the third case we have the velocity of the source is greater than the velocity of sound. That is Mach number greater than 1, Mach number equal to 1, and Mach number less than 1. This time we have a propagation of a sound wave. In left side it is more as compared to the right side. And when we have Mach number equal to 1, then it will propagate to the one side and no propagation is possible on the right side. That is, this one is called as zone of silence and this one is called as zone of action. When we have Mach number is greater than 1, so we will get a pressure propagation in this form. So these are all spherical forms here, and the radius will go on increasing depending upon the Mach. For this tangent it will going to form a cone. So if it is extended it will going to form a cone. This cone is called as Mach cone. So let's discuss this in detail now. When we have a Mach number is greater than 1, wave fronts will pile up along the side and the wave crest overlap one over the other and form a large amplitude wave which is known as the shock wave. Consider we have a source at point A. The source will reach in time t a distance equal to v. So let's say here this distance will be equal to distance v, which is traveled in 1 second. 2 seconds the source will reach to the point a double prime at a distance equal to 2v. 3rd second it will reach to a3 prime. Say this distance equal to, in 3 seconds it will cover a distance equal to 3v. This time we'll demonstrate for Mach number greater than 1, which is v by c is greater than 1, v is greater than c. That is, the velocity is greater than the velocity of sound. Say source is at point a prime, then the velocity is equal to v, and you have to draw here a circle with a radius less than v. So let's show here. We have a circle with centered at a prime will be like this, and this radius is less than the velocity v. Drawn here a circle with radius equal to c, and this value of c is less than the distance between a and a prime, that equal to v. Say for example here we have v is equal to 500 meter per second, and we'll take the velocity of sound equal to 250 meter per second, exactly halfway. So Mach number right now is equal to 2. For this we'll discuss this propagation of sound wave. When it will cover a distance equal to 2v, then the sphere is developed at a double prime of radius equal to 500, which is twice the radius of this. And with a double prime as a center, and you have to draw a radius of 2 times 250, that is 500 here. So likewise we'll get here the spheres are propagating in rightward direction. When the source is at a triple prime, in that case the distance traveled equal to 3v. So we have 250 multiplied by 3, 750 will be larger size of sphere is formed here. So that I will show like this. If you draw here a tangent to all this sphere, you will get a cone here, and this cone is called as Mach cone. If you draw all these tangents here from point A to all these ears, in that case we'll get a critical surface, and that critical surface is called as Mach Cone. And this tangent line is called as Mach line. And this region which is inside the cone is called as the zone of action, where you can hear the sound. And outside this one there is no disturbance here, so this one is called as zone of silence. The same propagation we can discuss for Mach number equal to 1 and Mach number less than 1. So this cone angle, if I shown here, this one is called as alpha, is a semi-cone angle, is called as Mach cone angle. If we take here any circle here, so I taken the first sphere of distance equal to v, and the radius of this sound wave is equal to c. So this time we can define sin alpha. Sin alpha is opposite upon hypotenuse, which is equal to c by v. C by v is same as 1 upon Mach number. Alpha here is called as Mach angle, and you can very well calculate this Mach angle by taking the sine inverse. This time you have to take the sine inverse of 1 by Mach number. So this is the concept of the zone of silence, zone of action in the case of Mach cone, when we have Mach number is greater than 1. Projectile travels in air of a pressure of 10.1043 Newton per cm square at 10 degrees Celsius at a speed of 1500 km per hour. Find the Mach number and Mach cone angle. So this time the pressure is immaterial for us. We'll only take temperature, that in Kelvin will be equal to 283 Kelvin. We have velocity is equal to 1500 divided by 3.6 is 416.6 meter per second. We can calculate the velocity of sound as under root of gamma RT in the case of air. Nothing is given, we can take gamma equal to 1.4, R equal to 287, temperature is given as 283. So we have velocity of sound in air will be 337.2 meter per second. In that case we have Mach number will be equal to V by C, which is same as 416.6 divided by 337.2 is 1.235, and Mach cone is only possible if Mach number is greater than 1. We have Mach cone angle alpha equal to sine inverse, that is basically semi-cone angle, is sine inverse of 1 by m. So we have sine inverse of 1 by 1.235 equal to 54.04. Supersonic aircraft is traveling with a constant speed of Mach number equal to 0.7 at altitude of 4 km. How much time it will take to travel a distance equal to 2000? From ground level, plane is flying at an altitude of 4 km, z equal to 4 km. And this one is plane position. At this point, we need to calculate what is the temperature. Let's assume here that at sea level we have temperature equal to 300 Kelvin, and we have temperature lapse rate will take standard value equal to 6.5 Kelvin per kilometer. Using this we can calculate temperature at the altitude of 4 km, and this plane has to cover a distance equal to s equal to 2000 km. For this one we should know what is the velocity of jet. We have a temperature at z equal to 4 km will be equal to T is equal to T0 minus temperature lapse rate multiplied by z. We have T0 equal to 300, lapse rate is 6.5, and we have z equal to 4. So the temperature at the given altitude will be 274 Kelvin. Corresponding Mach number is known, which is equal to 0.7, and we can very well calculate the velocity of sound, which is given by under root gamma RT. So just put here gamma equal to 1.4 for air, R equal to 287, temperature T equal to 274 at altitude of 4 km. We have velocity of sound is 331.8 meter per second at the given altitude. Since we have Mach number is given as V by C, so we have V is equal to M into C, which is equal to 0.7 multiplied by 331.8 is 232.6 meter per second. Since we have distance equal to v multiplied by t, we have distance equal to 2000 into 10 to the power 3. Velocity is 232.6. So from this we can calculate time. It will be 8610 second. Approximately 2.4 hours. Hypersonic aircraft passes by at a Mach number equal to 2.2, which is a supersonic, and a height of 2 km. How far ahead must one try to look for it when one hears a sonic boom? Consider here a plane which is moving with a Mach number equal to 2.2. Below this we have a observer. We have sin alpha equal to 1 by m equal to c into t divided by v into t. Now this time we have Mach number is 2.2. C into t is the distance traveled by the sound wave from the plane to the observer, which is equal to 2 km. In the meantime, the plane will travel a distance equal to v into t, which is equal to s. So we have s equal to 2 into 2 points. So he has to look ahead at a distance equal to 4.4 km to find the position of the plane.